Hello and welcome to SETI Live. I'm your host, Beth Johnson, Communications Specialist here at the SETI Institute. Welcome to all our viewers from around the world. Please let us know where you are watching from. We thank you for joining us. Also, welcome to listeners on the podcast version of SETI Live, available on most podcast platforms. Today, I have the pleasure of being joined by Professor Dagomar Degroot of Georgetown University, whose new podcast, The Climate Chronicles, quote, takes you on a journey through 50 million years of climate change, end quote. So, Dagomar, thank you for being here. Thank you for joining us. Welcome in.
Well, thank you so much. It's such a pleasure.
So let's kind of kick this off with something fun. Are we doomed?
We might be. I sure hope not. Now, because of climate change, I'm inclined to be a little optimistic. I don't think that humanity is doomed, but I do think that we are destined for some profound changes, and if we're not careful, a whole world of hurt. And are we doomed? People often ask me that question, and they mean, is humanity literally doomed to extinction? But as the climate scientist Kate Marvel says, we should aim for maybe a little bit more than that, right? we should try and have a future where we're better off, not worse off, right? And shooting for a future in which we don't go extinct is probably not enough. We should aim for more than that. So my sense is that because of climate change, we're probably not doomed to extinction. There are other challenges, though, that intersect with climate change. Mm-hmm. For example, AI. And other threats. So the combination of existential challenges that we face right now could drive us to extinction. Climate change by itself probably won't do it.
Now, I know some of our audience may be asking, why do SETI care about climate change or any of this? And to speak to that a little bit, I always refer back to the Drake equation. One of the things is how long can a civilization last, particularly a technologically advanced civilization. So your podcast explores climate change all throughout humanity, essentially. Have we had civilizations come and go?
We have had civilizations come and go. We've had sapient species, and by sapient I mean creatures that are able to reason like we can. We've had sapient species come and go. It's very possible now that the Neanderthals, for example, were as intelligent as we are, or almost as intelligent as we are, but they lasted only a few 100,000 years, and they disappeared. As one of the episodes in the podcast covers, they disappeared probably because of pressures that involved and were set in motion by climate change. In SETI, we often ask, are we alone in the universe, right? And how can we find out whether we're alone or not? But the truth is, we were not alone. When humanity evolved, we shared this planet with many others intelligent sapient species, at least 6. And those species went extinct. And our best guess is that climate change is strongly implicated in their extinction. It's difficult to know for sure. Maybe it's a combination of climate change and human pressures. Maybe we outcompeted our sapient cousins, what we call hominids, other creatures like us. But the bottom line is that, yes, we've had intelligent life on Earth, and it didn't last very long. Climate change was responsible. So I think looking at the history of climate change for that reason alone has profound implications for SETI, because it can tell us something about, what causes species to go extinct? What might be the reason that we're alone in our corner of the galaxy, or maybe even in the universe? But beyond that, and thinking beyond extinction, it might also explain something about how we got here in the first place, how we got so smart. Because as the podcast explores, it may be that we evolved intelligence in order to cope better with climate change. So it may be when we look at different exoplanets, right, looking for those things that might be associated with the emergence of intelligence, perhaps one of those things is going through a series of climate changes that would force species to adapt. And potentially one good adaptation is development of intelligence. Because that's something that the podcast covers as well. we really evolved in a weird time in Earth's history when the Earth was unusually cold. And because it was unusually cold, it was also unusually unstable.
Mm-hmm.
So it's that combination of climate change, instability, cooling that made us what we are.
So I want to talk to you some more about that, but let's welcome in some viewers first, and then we're gonna talk about your podcast. So welcome in to people joining us from Brazil, from New York, from Colombia, Pennsylvania, Louisiana. So yay, thank you everybody for joining us. I hope that you are living someplace where the climate is lovely. So let's talk about your podcast. So how did this podcast come about? What was the motivation for it?
Well, there's a few different motivations, but honestly, one of them is that when my students want to learn something, they don't go to a book anymore. A lot of them will go to a podcast or a YouTube video or something online. And I realized, actually, honestly, I realized this when I was doing an event with SETI a couple of years ago. And we had a panel of young people, students. And they were asked, how did you get interested in SETI? And they told us, well, we went to a podcast, or we found a website, found a YouTube video. And so then I was thinking, well, maybe I should try something like this too. But the difficulty of exploring that new medium, because this Climate Chronicles has video trailers, and it has audio, and audio has to be like it has to be good, as you know. It's not easy to make good audio, so that was pretty daunting. But then, really, in the last couple of years, the development of large language models and their ability to do many different things, like even cleaning up audio files, or creating video trailers that are actually dynamic and really capture the attention of young folks in particular. It reached a point where I thought, okay, I can try this now and see if I can do everything by myself, because I really like the idea of doing something creative. And then telling the history of climate change, I just think it's such a fascinating story. It's an important story. It's important for SETI, as we've discussed. I think it's important for our understanding of what the future will look like on Earth, because as you can see when you listen to the podcast, the past really tells us a lot about how sensitive climate is to human greenhouse gas emissions, for example, or what sort of strategies work in coping with climate change, and what sort of things don't work. History has a lot to tell us about that. But more than that, it's just to me, a really fascinating story. It's a story that I've devoted my life to. It's something I find endlessly interesting. And the science is always changing. The scholarship, I shouldn't say the science, the interdisciplinary scholarship about how climate changed and how people responded is always evolving. It's always changing. So being able to tell the story also about why it's changing, how it's changing, how we know what we think we know about the past. I just have, obviously, you can probably tell, I have a lot of enthusiasm for it. And I wanted to share that.
And your passion comes across in the podcast, I have to say. I've listened to the first season, and it is really good, and it keeps you interested, and the storytelling really is vibrant, and it makes you feel like, okay, I see it. I see what was going on. I understand. So congratulations on that. That is really, really well done. And the fact that you just said you're doing this by yourself, you are a one-person show.
Yeah, I'm a one-person show. I've got a book coming out later this year, and it's a trade press book, so it involves like a ton of editing. Really, it takes a village, right, to get a book out. Partly in response to that, I wanted to have full control over this podcast, and also it was really an opportunity to be a bit creative. A lot of the work I do these days is in science. So it's, science is a creative act, but it's not creative in terms of, making art, really. And that's one of the things that we've tried to do with SETI. We do a Earth at the Crossroads event where we combine science and art, think through environmental challenges on Earth and possibly around the galaxy. And that combination of art and science, which I saw in Earth at the Crossroads, must have done something to me, because I wanted to try that too with the Climate Chronicles. And so I'm developing music and developing these video trailers and the website. And I've learned a lot. Steep learning curve, but I feel like I'm learning a lot. And whenever I'm learning and outside of my comfort zone, that also makes me pretty enthusiastic. I love that. So,
like I said, I'm really enjoying it, and I'm looking forward to listening to season 2, which is already coming out. So, talk about the plan for it a little bit. So, how many episodes are planned? What's the mission, and who do you see as your audience?
Sure, it's a little crazy, honestly. It's right now I'm planning 42 episodes in 8 seasons, and the total number of words, because I write these things out and then I partly follow a script, sometimes ad-libbing, but the total number of words is probably going to be about 220,000. So that's the equivalent of 2 good-sized trade press books. So it's daunting. I'm just finishing season 2, so we're about quarter of the way through.
Mm-hmm.
And the idea is to take it all the way through the present, with the final episode focusing on possible futures, where we might end up at the end of this century. So the next season will be, I should break it down a little bit more maybe. The first season is about human evolution.
Mm-hmm.
And then the second season is about how do we survive this extraordinary period of climate change, which happened in the Pleistocene, get out of that and make it into the Holocene, which is the name for the geological epoch in which we might currently live, when Earth's climate was a bit more stable globally. And we were able to build the foundations for what we often think of as civilization, like agriculture, cities. So the next season will focus on that, how we developed agriculture, how we developed cities and towns, and how that altered our ability to cope with climate change, both making us more vulnerable and more resilient. It'll talk about some of the ways in which the first empires coped with climate change, with drought, because even if the Holocene globally was more stable climatically, on a regional scale, you still had huge changes, like the Sahara actually turned into a desert not that long ago. So the next season we'll talk about that transition into a desert as well, and how it might have been the origin of ancient Egypt. And then after that, we start talking about the ancient world. So past the first empires, getting into classical Rome and China, and then moving into the Common Era. So the last 2,000 years, spend a good long time focusing on a period of climatic cooling called the Little Ice Age, which we know a lot about. And because we know a lot about it, we can zoom in on specific case studies where different populations may have coped better than others and came into conflict and developed different kind of cultural expressions, maybe partly in response to climate change. And then we survey the history of global warming. And I think this is really important, because we often think of global warming as an issue of the present and the future, but it's been happening now for several decades. So we'll explore how different populations have already coped with global warming, from the far north into the Middle East, thinking about things like, did the Syrian civil war start partly because of droughts that were worsened by climate change? How are Inupiat hunters responding to the retreat of sea ice, thinking about those kinds of issues? And then again, we'll focus on whether we're doomed, and what the future might look like.
So you brought up the Little Ice Age, and I think this is an important distinction that you caught my attention with in the podcast. So my father and I have had this disagreement for decades about climate change. And he will look at you and say, no, we're in an ice age. It is, the planet is supposed to get cooler. But when I was listening to the podcast, you started discussing the difference between an ice age and an interglacial period.
Mm.
And I think it's a really important distinction. So can you kind of explain to the audience a bit? I mean, obviously, everybody go listen to the podcast. Dagomar does an amazing job of explaining the basics one step at a time. But I do think this is a really relevant and important distinction to be made. So will you explain that for everybody else?
Absolutely. Yes. So it's going to be a little contradictory. So on the one hand, we are in an unusually cold period in Earth's broader climatic history. So the Earth has usually been too warm for there to be any ice sheets. An ice sheet is just a name for a glacier that's really big. So for there to be any ice sheets anywhere on Earth, the Earth has actually historically been usually too warm for that. So on the one hand, we're in an unusually cold period. So put that aside. And that unusually cold period, you can call it an ice age. An ice age is really any time when there are ice sheets on Earth. And obviously, thankfully, we still have ice sheets on our planet, right? On Greenland, Antarctica, actually covering 15 million square kilometers. There's lots of ice, mercifully still on Earth, right? So we're still actually in an ice age. Now, an ice age is different than a glacial or a glacial period. And often they're conflated. You know, in popular culture, we think of an ice age as a time when these ice sheets cover a huge part of the Earth, about a third of the Earth, pressing all the way into the United States, right? So you might think,
right.
Ice sheets covering New York, on the verge of Washington, D.C. here. I might see them from my window.
Michigan,
Chicago.
Minnesota, all the way down, yeah.
Yeah. That's actually called a glacial period. So you can't have a glacial period without an ice age, but you can have an ice age without a glacial period. So we are actually now in an interglacial period,
okay,
which is a warmer stretch in an ice age, but not a glacial period, right? So it gets a little complicated. And the upshot is that yes, if you look at multi-million, tens of million, hundreds of million year timescales, we are in an unusually cold stretch right now.
Mm-hmm.
If you look, however, at the last few million years, then we're in an unusually warm stretch, right? So if you zoom in on the last few million years, now we're in an unusually warm stretch. And if you look at the rate of change, right, in our climate, that rate of change is really extraordinarily fast with very few, if any, parallels. And if you look at how warm the Earth will be at the end of this century, well, there's absolutely no parallel in human history, and probably no parallel in hominid history. So that's our family of animals. So I hope this all makes sense. It's almost like by changing our climate, we're stepping into a time machine, right? We're moving into the world of the past when the world was warmer. And that's a pre-human world. And you might even call it an anti-human world, because that world, that much warmer world, is one in which it's going to be very, very difficult for us to maintain our cities where they are, to maintain our agriculture, right? So that's the danger. It's not like we're killing our planet. Our planet has been through a lot. It's that we're killing us. That's why climate change is so serious.
So I still have a few more questions for you, but if those of you watching live have some questions, please feel free to put those in the comments. We are tagging them, and I will try to get to them if I can. So you're still researching, obviously, but this has been your area of research for your career. So far, what has been the most interesting and or surprising piece of information you've discovered in your research?
Honestly, it's the extraordinarily diverse, ingenious, and flexible ways in which past populations, armed with rudimentary technology and no sense of what was happening globally, were able to respond to climate change, adapt to it, and survive. That's been the That's been the North Star of my research, really. When I started, actually, many moons ago, longer ago than I like to think about now, I thought I was going to write a PhD dissertation on how climate change caused crises in a society during the Little Ice Age about 400 or 500 years ago. And I quickly found, as I was digging into the extraordinarily dense documentary record preserved by this society, the Dutch, that it was way more complicated than that. And actually, so some parts of Dutch society suffered, some didn't. Overall, Dutch society was pretty resilient to a period of climate change. Now, not one as big as what we're doing now of global warming, but still meaningful. And so I thought I'd uncovered an exception to the rule of societies collapsing in response to climate change. But it's really been one of the great discoveries, I think, of the last 10 or 15 years, and discoveries that I've been part of in some cases, that there are many of these kinds of examples of just populations that were able to adapt themselves fundamentally by maybe moving, by developing new technology, by developing new trading networks, or even cultural expressions, or even fighting, conquering their neighbors, but many different responses to climate change that were productive in different ways in very different contexts. Mm-hmm. So the latest episode that dropped yesterday is on a period of really abrupt, extreme climatic cooling in the Northern Hemisphere called the Younger Dryas, about 12,900 years ago. And this is so extreme. I mean, what happened was probably you had a ton of meltwater from retreating ice sheets spilling into the Atlantic Ocean, mm-hmm. shutting down Atlantic Ocean circulation. And this happened extraordinarily quickly. And when that circulation shut down, less warmth was transported into the higher latitudes in the Northern Hemisphere towards the Arctic and the subarctic. And so what happened then was a cooling, which in Greenland was more than 10 degrees Celsius on average, happening in just a few years maybe, or at most a few decades. So we think about change, it's a hell of a lot. and the human population is hard to determine just how many people there were. Even now that's hard to determine. But back then it was probably a few million. And you've got these groups then of, no more than 100 individuals. And they have to cope with climate change on this magnitude. And not only do many populations do it, but they continue living very far in the north, right? So far to the north, developing new technologies, or maybe, going to wetlands or harvesting fish, which are not as affected by the cooling. But I just find that so remarkable. Imagine that, you've got 100 people and they're armed with the most rudimentary technology, but they're still able to find a way to stay in the same spot, in the tundra, even as it's cooling that much. I mean, to me, that's actually, it's a disturbing story because it shows how much the Earth can change and how quickly it can change. Right. But it's also, I think, a really hopeful story, going back to whether we're doomed. Well, these people were able to survive, right? And I think that's pretty hopeful. We should be able to find a way to survive now. And of course, that begins with lowering our emissions so that we moderate how much we actually change the climate. But frankly, it also makes me a little bit hopeful. And I think that's important because so many of my students, young people, they feel like we're doomed. And if we're doomed, we don't have to change, right? There's nothing we can do. But I think this history shows us that there's a heck of a lot that we can do and that we're certainly not doomed. So that makes me a bit more hopeful.
So in your opinion, having done all of this research over the years, where are we headed as a planet climate-wise?
Well, there's still meaningful uncertainties. So the first uncertainty is how sensitive is Earth's climate to greenhouse gas emissions. And we're narrowing the range of that uncertainty. And it turns out, unfortunately, it's pretty sensitive, right? And there's I talk about that a little bit in the podcast. You can also visit the website, theclimatechronicles.com, to see some graphs. But if you were to plot global temperatures, millions of years into the past, and you compare that to a plot of atmospheric carbon dioxide concentrations, those plots line up really nice, right? It's really strongly correlated. So we know Earth is really quite sensitive to carbon dioxide and other greenhouse gases like methane. So there's that. The other thing to ask is, well, how much of this stuff are we actually going to pump into the atmosphere going forwards? And I'll say this, about 10 years ago, it looked like we really were on track for the worst case scenarios where our greenhouse gas emissions keep exploding up, soaring up exponentially,
Right.
leading to maybe 5 degrees Celsius of warming by the end of this century relative to the late 19th century average. And 5 degrees Celsius of warming, that's so much, and we talk about these glacial periods. In a glacial period, the Earth was about 6 degrees Celsius colder than it was in the 20th century. So about 7 degrees Celsius colder than now. That's in the deepest and coldest glacial period. So like the last glacial maximum, which I talk about in the most recent episode. And you just think, okay, so when the world was that much colder, what did it look like? Well, it was, a third of it was covered by ice sheets.
Mm-hmm.
And dust levels in the atmosphere were up to 20 times greater, depending on where you were. It was incredibly dry, incredibly cold. So again, going back to the resilience of our ancestors. What I mean to say, though, is that 5 degrees Celsius of warming in 1 century, that's apocalyptic, right? So that was 10 years ago. We were on pace for that. But a couple of things have changed, thankfully. One is that the cost of renewables has collapsed. So in many parts of the world now, solar and wind power are actually cheaper than coal power, which is really a revolution. And things like electric cars, like Tesla, and all the anger at Tesla and the collapsing sales. BYD in China is exploding. Electric car sales are way up. Electric cars do use a lot less carbon dioxide than internal combustion, or even in many places hybrid cars. So one example. The green economy is really doing well. There's still a ton of investment globally in the green economy, and a lot of countries and governments, even at the municipal level, have accepted climate pledges, which are and commitments to climate action, which are pretty strong. So as a result of that, if you just imagine, we all talked in COVID about bending the curve, right? You want to bend the curve, at least in the first outbreak, we talked about bending the curve. Well, the curve of global greenhouse gas emissions has been bent. So that's good. And as of about 2 years ago, we were on pace for maybe 3 degrees Celsius of warming by the end of the century. So, but you just think, right, the difference between 5 and 3 degrees Celsius seems like it's only 2 degrees Celsius. And I talk about this in the podcast at some length. Appearances can be deceiving, because those 2 degrees Celsius, when they're averaged out globally, that's just a huge amount, right? And that changes, for example, the number of heat waves by dozens of times, or it changes the magnitude of the heat waves you can expect to receive by an enormous amount. And it really means those 2 degrees Celsius means a galactically enormous reduction in danger. So I think that's one of the best things that has happened in our lifetime, that we've bent that curve. Now, in the last 2 years, our progress has stalled, and in some cases even things have gotten worse again, because what we're seeing now is a number of banks and corporations seeming to retreat from their climate pledges, or a number of countries that have decided climate action isn't really as urgent as we thought, So we're going to prioritize fossil fuels. This is partly in response to the Russian invasion of Ukraine, where there was an energy crisis in Europe, for example. And of course, now we also have political change here in the United States that threatens to really undermine our progress in lowering emissions and in bending that curve, that future greenhouse gas emissions. So I don't know, whether you feel hopeful about this or not is really, it's in the eye of the beholder. For me, I feel very mixed right now. And that's why I said also that I don't view climate change as an existential threat, meaning it could really kill us all. But partly because we've bent that emissions, but I still think, this is still an oncoming train. And, it's frustrating because we still have the capacity to make that train stop entirely before it really hits us.
Right. So we're at our half hour, but there is one audience question I want to pull in, and then we're gonna wrap up here. But PT South 97 asks, do you have any thoughts on potential geoengineering solutions for climate change?
I have very strong and controversial thoughts on geoengineering. I run this exercise actually with my students, geoengineering, sort of brainstorming with my students. My hot take on geoengineering is that it's inevitable. And the reason that I think it's inevitable is that currently the projected costs of maintaining something like solar radiation management, where you inject aerosols, you can think of them like little particles into the stratosphere to reflect incoming solar radiation. The projected cost of doing that is very, very low compared to the current, let alone the estimated future damages inflicted by global warming. And so my sense is that these solutions, I use scare quotes because there are all kinds of consequences to geoengineering, altering precipitation patterns, for example, and potentially causing all kinds of geopolitical tensions. But the potential costs of doing it relative to the benefit is it's going to make it an irresistible option, I think. And the other thing to bear in mind is that it can be done unilaterally. So there's actually a book about this by Kim Stanley Robinson, which you may have read, where India is afflicted by this enormous drought, famine happens, and India decides to unilaterally geoengineer the world. That's a very realistic scenario in my view. So I think it's going to happen. My sense is it'll happen within 20 years. And once we're doing it, it'll be very difficult to stop.
It's a lot to take in, Dagomar. It's a lot to take in.
Actually, the final episode of the podcast will survey possible climate futures. And one of them will be a geoengineered world. So the most likely world to me by 2100. And then in that world, the climate will be as warm as it is now, or maybe even a bit cooler, because we'll probably be able to control the thermostat of the world to some extent. But it'll be fragile, right? It'll only be like that so long as we keep geoengineering. Mm-hmm. And whether you consider, again, it goes back to this, right? Whether you consider that a success story or not, it will be in the eye of the beholder. Actually, if I can say one more thing about this, it reminds me of COVID, where, when COVID hit, it seemed like we had an option, right, of really reducing the spread of the disease.
Right.
And arguably, a lot of this is still unsettled, and we're still trying to figure out exactly what happened. Arguably, we chose not to do that in the United States, but we did develop these vaccines, right? And the vaccines or prior, exposure to the virus, they saved a lot of people. And I think it's a little bit like climate, right? We're going to be hit really hard by this. Then we're going to develop these geoengineering solutions that are going to be very imperfect, and a lot of people are going to die who don't have to die. And in the end, it's going to be a real mess, but we'll get through.
I feel like that's a statement for everybody right now. Everything's a mess.
Yeah, I hope so.
So before we wrap up, what's next for the podcast and what's next for you? You're currently at the Library of Congress, but that's wrapping up soon. So what's next for Dagomar?
Well, I have a book coming out this year called Ripples on the Cosmic Ocean. And that book, there's going to be aliens in the book because it's going to be a book that shows how changes in what I call cosmic environments have influenced the last 5 centuries of human history, partly by making us think that there are aliens. So there's going to be SETI implications in that book. It's going to be a trade press book. The next season of the Climate Chronicles is going to be about the development of agriculture and really the world up to this crazy thing that happens called the 4.2 kbp, meaning 4,200 years ago, a massive drying event that probably brought about the collapse of empires, but in really complex and interesting ways. So the next season will focus on those things, the emergence of Egypt. There's going to be a lot of stuff there. And then I'm working on a book on existential risk as well. So again, these risks that could wreck everything. And it's going to focus on the early space age, when it seemed like there was a real possibility that astronauts would bring microbes to other planetary ecosystems that would break those ecosystems, or bring microbes from other planets back to Earth that would break the Earth. So it's going to be a book on how scientists tried to prevent what they considered was an existential risk, and why they would have failed if indeed those microbes had existed.
So Dagomar, thank you for joining me today. I want you to come back when that first book comes out. I would love to get my hands on that and talk to you about it. Congratulations on the Climate Chronicles. I hope that this becomes a success in whatever terms you judge that to be for you. And I could talk to you all day. I could listen to you talk all day. So you just everybody go and listen to Dagomar's podcast. You can find it at the climatechronicles.com. And we were sharing out the episodes weekly from our social media accounts. So if you miss something, you can go back and find previous episodes there too. And Dagomar, thank you so much for being here today. Really appreciate the conversation.
Thank you so much. And thank you to SETI for all the support. It is so appreciated.
We are the SETI Institute, a 501c3 nonprofit. We rely on your donations to keep outreach programs like this one happening. So if you can and you feel like you want to, please go to SETI.org and click the donate button. And we will be back next week. I will be talking, hopefully, jury duty pending, with one of our scientists about Mars and Martian clays. So we will be back then. Everybody have a fabulous rest of the week, and thank you for joining us. Thank you again, Dagomar.
Thank you.